welcome to all of you in our online lecture series of subject mathematics. Dear students, in the last few videos we have already discussed about the derivatives of composite function and also derivatives of inverse or inverse trigonometry function. Theorem, proof and examples are already discussed in the last few videos. Now let us here discuss another very important concept of the differentiation, and that is nothing but that is the logarithmic differentiation. Okay, the concept of logarithmic differentiation, when you have to look this name logarithmic differentiation, then in your mind that is the given function are in the form of logarithmic, then we have to use the logarithmic differentiation. But that is the not case, because when the given function in the form of composite function or in the form of inverse function, then we have to use these methods of composite functions and inverse functions methods. But when the given function are in the form of logarithmic form or function in the form of logarithmic, then you does not apply this logarithmic differentiation. Then when you have to use this logarithmic differentiation, when the given function are in the form of, that is the product of any two functions, that means when you have to want to find the derivatives of complicated function which are expressed in the form of, that is first one, if the given function in the form of product of a number of functions, that means when the function 2 or 3 or 4 functions which are in the form of product form, then we have to use this logarithmic differentiation. Okay, for an example you have taken here for one example, that is if the given function in the form of x plus 1 bracket raised to 3 by 2 into twice x plus 3 bracket raised to 5 upon 2 into 3x plus 4 bracket raised to 2 upon 3. Here there are first term, that is x plus 1 bracket raised to 3 by 2, that u into v, that is 2x plus 3 bracket raised to 5 upon 2 into w, that is 3x plus 4 bracket raised to 2 upon 3. That means here the given function in the u into v into w form, that means the product form, and also each u are in the exponential form. Then you have to be applied this logarithmic differentiation. Okay, now another, that is the if the given function in the form of quotient of a function, that means given function in the form of, yes, that is in the form of fraction, that is in the form of numerator and denominator. Numerator is a function and denominator is another function, then you have to use this logarithmic differentiation. That for an example you have to take on, that is in the numerator, that is x plus 1 bracket raised to 2, that is the function, and in the denominator, that is x plus 2 bracket raised to 3 into x plus 3 bracket raised to 4. That means again in the denominator the given function in the form of product form. Then in that case also we have to use this logarithmic differentiation, because that type of function you cannot find the derivatives of that type of function by the help of our only formulas. Okay, and also this method or logarithmic differentiation used when the given function in the form of f of x raised to g of x, that means the given function in the form of, yes, that is index form or exponential form, where base is our function and also index is another any function, then you have to also use this logarithmic differentiation. That is, if you have to take one example, that is if the given function in the form of sin x bracket raised to x, here sin x is our base which is a function, and raised to x, x is also again a function. Then if we have to find the derivative of the given function, then here is also we have to apply the logarithmic differentiation. Okay, that means if the given function in this format of product, quotient or in the exponential form, then it is convenient to find the derivative of the logarithm of the function by using the laws of logarithm. That means that type of function have to be solved by the logarithmic differentiation. That means firstly take the logarithm of the given function, apply the laws of logarithm, and then by taking the derivatives of logarithm, you can find or we can solve the examples of that type. Okay, hence this method of finding the derivatives of a function is known as logarithmic differentiation. That means if you have to first let the given function which are in the form of product form, quotient form or exponential form, firstly take the log of both the sides of the given function, then apply the laws of logarithm, and then we can find out the derivative of the given function. That whole process of finding this derivative is called to be an logarithmic differentiation. But when you have to take the logarithmic differentiation, that is that when you have to take the derivative of logarithm, then we have to apply the chain rule. That is not by chain rule we have to take, that is d by dx of log of y equal to d by dy of log of y into dy by dx, because here the given function in the form of y and we have to take the derivative with respect to x. Therefore, by applying the chain rule, that can be written as, that is d by dy of log of y into dy by dx. Here dy become cancelled, only remaining is d by dx of log of y. Only we have to apply the chain rule, that is d by dy of log of y, that is the log of y having the derivative with respect to y, that is 1 upon y into dy by dx. That means the derivative of log of y with respect to x, that is 1 upon y into dy by dx. Okay, that is very important. That have to be taken in the each and every example of the logarithmic differentiation. Okay, now we are discussing some laws of the logarithm which are to be already discussing in the 11th standard. Here we have to recall these laws of logarithm because all these laws are very important. First law is, that is log of m into n equal to log of m plus log of n. That means when the given function in the product form, m and n are the two functions which are in the form of product, and if we have to apply the law, then we have to get, that is the log of first function plus log of second function. That means product of the two functions having the logarithm is nothing but sum of the log of the given two function. Okay, now the next formula or laws of the logarithm, that is log of m upon n equal to log of m minus log of n. Here the given function in the quotient form, that is m upon n, is in the fraction form, and if you have to take the in the quotient form or fraction form, and if you have to take the logarithm, then having the value is always taken to be log of m minus log of n. That means function in the form of quotient form, then take the log of both the function and take the difference of the given two logarithm. Okay, that means log of m upon n equal to log of numerator minus log of denominator. Okay, that is the second law. Now the third law, if the given function in the form of m raised to n, that is in the exponential form, then we have to apply the logarithm rule, that is log of m raised to n equal to n into log of m. That means here m is the base and n is the index. Then n, that is index, are taken to be product form, that is n into log of n. That is very important. These are the three important rules. Now the next formula or laws of the logarithm, that is log of 1 to the base a equal to 0. That means if you have to take logarithm of 1 of any base, if you have to take log of 1 to the base 5, that is also 0. Log of 1 to the base 10, that is also 0. Log of 1 to the base e, that is also 0. That means if you have to take any base, always logarithm of 1 is 0. Okay. Now the next very important, that is fifth law. If the given function having the base is b and given function is a, and if you have to take log of a to the base b, if you have to change our base, then therefore that law is called to be a change of base law. If you have to change base of the logarithm, then we have to apply that laws or formula, that is log of a to the base b equal to log of a to the base c upon log of b to the base c. That means here we have to change, in the given function the base is b, but if you have to change that b in the form of c, change the base from b to c, then that change of base law is applicable, and that is log of a to the base c divided by log of b to the base c. For an example, if the given function, that is log of 5 to the base 10, okay, and if you have to convert the given function or logarithm in the form of to the base e, then that function become, or the logarithm become, that is log of 5 to the base e divided by log of 10 to the base e. Okay, because when you have to take the derivatives formula, then we have to compulsory the base is e. When you have to apply the formula d by dx of log of x equal to 1 upon x, then the base of the given logarithm must be e. If the given function which are having the base is 10, then firstly convert the given base 10 into e by that law. Okay, and the last law, that is log of a to the base a always equal to 1. That means the given logarithm having the number a and the base is same, then always logarithm of the given function is equal to 1. That means log of 5 to the base 5 equal to 1, log of 10 to the base 10 equal to 1, log of e to the base e always equal to 1. These are the important 6 laws which are to be used to find out the logarithmic differentiation. That means firstly take the log of both the sides of the given function and then apply these laws of logarithm, simplify the given function, and then take the derivative of the given logarithmic function. We can get the derivative of the required function. Okay, this is the procedure to find out the derivative of the logarithmic differentiation. Okay, now let us take here one simple example of the logarithmic differentiation. Okay, the given example is differentiate the following function. The function is y equal to x raised to x. Here in the given function, the base is our x and exponent, that is also x. That means f of x bracket raised to g of x, that type of the given function. Now we have to find the derivative of the given function. Then the given function in the form of exponential form, and therefore we have to take the logarithmic differentiation. Therefore taking the log of both the sides of the given function, and therefore we can get the function, that is log of y equal to log of x raised to x. Okay, here in the right hand side the given function again in the form of log of x bracket raised to x. Now we have to apply here the formula of the logarithm, that is log of m raised to n equal to n into log of m, and therefore the given function become, that is log of y equal to x into log of x. Okay, that means this is the function which have to be differentiated now. This function is ready for differentiation. Now taking the derivative of the both the sides of the given function. We know that we are already discussing by the chain rule, that is the derivative of log of y is always equal to, that is 1 upon y into dy by dx, and therefore the derivative of left hand side is 1 upon y into dy by dx equal to, again in the right hand side the given function in the form of product form, that is x into log of x. Therefore we have to apply here the product form of the differentiation, that is first function into derivative of second plus second function into derivative of first, and therefore d by dx of x into log of x, taking the derivative of both sides. Therefore 1 upon y dy by dx equal to, apply the product rule, that is first function x into d by dx of log of x plus second function log of x into d by dx of first function, that is x. Okay, and therefore the next step becomes, that is 1 upon y dy by dx equal to, here in the right hand side x into derivative of log x always equal to 1 upon x, because log of x having the derivative with respect to x. Therefore the derivative is only 1 upon x. Okay, and therefore that is x into 1 upon x plus log of x into derivative of x, that is 1. Okay, and only simplify here, x and x become cancel, only remaining is 1 plus log of x, and therefore 1 upon y into dy by dx equal to 1 plus log of x. Now here in the left hand side 1 upon y into divided by dx, we have to find the value of only dy by dx. and therefore y have to be taken in the right hand side, and therefore the given function becomes, that is dy by dx equal to y into bracket 1 plus log of x. Now substitute only the value of y, that is y equal to x raised to x in the given equation. Then the given function becomes, that is the derivative becomes, that is dy by dx equal to x raised to x into bracket 1 plus log of x, and that is the derivative of the given function. That is a simple process to find out the derivatives when the given function in the form of product form, quotient form, or in the exponential form. Then by this logarithmic differentiation we can simplify the given function and then take the derivative of the given function. Okay.